Good day to all of you. We are here to share information about the things we have learned about
Dividing polynomials.
using long division and synthetic methods.
Pose with the fans. Pose with the pose with the put the pose with the fans. Pose with the pose with the pose with the fans. Fans. Pose with the fans.
Mathematics.
For our objectives, first we have to identify when to use long division or synthetic division. Second, perform both methods to divide polynomials accurately. Third, identify the conditions when polynomials long division or synthetic division is applicable. Fourth, compare the two methods in terms of steps and efficiency.
Before we proceed to discuss about these two methods, let us first know what is polynomials. What is polynomials?
Polynomial is an algebraic expression that consists of
one or more terms.
Note, in dividing polynomials, you cannot divide them whether using long division or synthetic if they are not arranged in their descending power.
If so, you may add 0x to the power of n to the given equation to arrange it in descending power, where the value of n is the missing exponent. For example, 3x cubed minus 6. As you can see, we have missing powers or missing terms, and as we said, we cannot proceed on dividing without those missing powers or terms. So, from 3x cubed minus 6, we write it as 3x cubed plus 0x squared plus 0x minus 6. Now we have arranged it to its descending power, we can now proceed on dividing it. Another example, 5x to the power of 4 minus 12x cubed plus x squared minus 43. As you can see, we still have a missing power, so we write it again as 5x to the power of 4 minus 12x cubed plus x squared plus 0x minus 43. Now we already know how to arrange the polynomials to its descending power. We may now proceed on dividing polynomials using long division and synthetic method.
So here's our first example. So the given equation is x cubed plus 2x minus 36 divided by x squared 3 using long division. As we said, we cannot proceed on dividing a polynomial without arranging it with descending. So to arrange it accordingly, we need to add 0x to the end on the missing power. Then, x cubed plus 2x minus 36 becomes x cubed plus 0x squared plus 2x minus 33. So in dividing polynomials, we need to divide the first term of the divisor with the first term of the divisor. So x cubed divided by x squared plus 2x. So we multiply the constant to the divisor. So x squared times x is equal to x cubed. X squared multiplied by negative 3 is equal to negative 3. So since x cubed is positive, we change it to negative. And since 3x squared is negative, we change it to positive. Since x cubed has a right sign, we subtract. So x cubed minus x cubed is equal to 0. And since 0x squared and 3x squared has the same sign, then we add. So 0x squared plus 3x squared is equal to 3x squared. Then bring down the remaining terms. Plus 2x minus 30. So repeat the same process. So 3x squared divided by x is equals to 3. Then multiply. 3x squared. 3x times negative 3 is equals to negative 9x. Change the sign. Since they have different signs, then we subtract. Since they have the same sign, then we add. Then bring out the remaining term. Then divide 11x to x. 11x divided by x is equals to 11. Then multiply 11 to x minus 3. 11 times x is equals to 11x. 11 times negative 3 is equals to negative 30. Change the sign. Since they have a like sign, then we subtract. Since they also have a like sign, then we subtract. So this is our remainder, and this is our quotient. Therefore, our quotient is x squared plus 3x plus 11, and our remainder is negative 3.
So now we'll be solving the same equation, but in a different method, which is the synthetic method. Here's the synthetic method. We can only use this formula if our divisor is in linear term, which is this is an example of a linear term. So, as you can see, this is still not in their descending power. So, instead of this, we will be writing it as x cubed plus 0x squared plus 2x minus 36. So, in synthetic, we're going to write the numerical coefficient of each term. So, x is 1, 0, 2, and then negative 36. And then in synthetic, we need to write it the inverted L. So we will be using this formula, which is x minus c. And then in this term, our c is negative 3. So x minus negative 3. And negative times negative is positive. So x is equals to 3. We will be putting 3 here. So now we'll be drawing a line. We will give it a little bit of space. So now we bring down 1. And then we multiply 3 to 1, which is 3. And in this section, we will be adding our numbers here. So 0 plus 3 is still 3. Then repeat the same process. 3 multiplied 3 is 9. Add 9 plus 2 is 11. Then repeat the same process. 11 times 3 is equals to 33. And since they are like terms, we will subtract. And since the bigger number is negative, our number will be negative in our answer. Now our quotient is x plus 3x plus 11. We will start with squares. Since our equation earlier was x cubed, we will be dividing it with x. So x cubed divided by x equals to x squared. That's why we are having this answer as our first term equation, and our remainder will be negative 3. As you have noticed, we have the same expression or equation using in different methods, but whether you're using synthetic or long division, you will still be having the same quotient and remainder or the same answer.